Hi, I'm Sunny Williams, and I'm an astronaut who's lived and worked aboard the International Space Station, an amazing research laboratory that's orbiting the Earth about 250 miles above us. While we're at the space station, we astronauts live and work in a microgravity environment. Do you think the laws of physics will hold up in the space station while experiencing microgravity? Let's check with NASA astronaut Mark Vande Hei on the International Space Station to find out.
Newton's first law of motion says an object at rest tends to stay at rest unless acted on by an outside force. Also, an object in motion tends to stay in motion unless acted on by an outside force, like my finger.
Let's look at this from another angle. Over time, the International Space Station slows down from experiencing a very small amount of drag, or force, from a tiny amount of atomic oxygen in space. This is like the force you feel from the air if you stick your hand out of a moving car. Because of this, the space station does what we call a reboost. A reboost uses rocket engines to put a force on the space station. This allows it to speed up just a little to remain in orbit around the Earth. Let's join NASA astronaut Jeff Williams to check out what happens to the objects inside the space station when it begins.
Now, the way I'm going to demonstrate the acceleration that comes during the reboost is by using this camera. 800 millimeter lens, so it's pretty massive actually. And you can see I can float it here, and there's no reboost going on right now, so the camera's not going to go anywhere. It's just going to slowly drift due to the ventilation, or if I put any velocity into it, it'll drift out of the scene. But I'm going to try to hold it here steady, and you can see that it stays very steady. There's my camera. I'm setting it up for ignition. There it goes. It actually came a little bit early. Now watch the camera accelerate toward you. There it goes. I'm going to reach out and grab it and bring it back in the view here. And I'm holding it. I'm actually feeling the acceleration. I'm going to let go again. And here it goes. It's going to take off. I'll try not to let it hit you. Just going to miss you. Yeah, I'm going to let go now. And here I go, drifting back toward you again. So the acceleration applies to me too. Reached our 2.7 meters per second that we desired, and now if I let go of the camera, it's not going anywhere, so the burn is over. Reboost complete. We'll stay in orbit for a little while longer.
Can you use Newton's first law to explain why the camera began moving without an astronaut putting a force directly on it? I'm going to send you back to class so you can start to investigate this with the Classroom Connection found at nasa.gov/demonstrations. Thanks for exploring a little physics on the space station with us today. See you again soon.